entomology for the University of Arkansas Division of Agriculture. He has worked and played with bees since 1998 and is equally at home in the apiary, the laboratory, or the classroom. Each year he presents lectures, workshops, and short courses for new and experienced beekeepers throughout Arkansas and beyond. He emphasizes the biology and behavior of bees as a cornerstone of keeping them productive and healthy. He also spreads the word about the importance of pollinators to the non-keeping bee public. John has a background in botany and entomology and is a certified master beekeeper. He and his family own Walnut Valley Honey Farm in Little Rock, Arkansas, producing good products from the hive and supplying pollinators for the area community gardens. I welcome John Z to the stage.
How's that? Whoa, there we go. All right, thank you. It's a pleasure to be here today and talk to you guys a little bit about pollinators. Y'all love bees? Oh, sort of. We've got mixed feelings about bees. Most people don't know a whole lot about bees. You know two things, probably. You know they make honey, and you know they have a pointy end we try to stay away from. That's about the only two things people know about bees, but they're actually really, really important because they do an amazing job for us. They're great for your gardens, for your plants. The only time you would not want to have a bee in your garden is maybe if you were trying to grow cut flowers, because when a flower gets visited by a pollinator, they consider that the job done, and they drop the petals, and they start the process of making seeds and fruits and things like that. But just about any other time, we want to welcome bees into the garden. So pollination, of course, is a very important step in the life cycle of the plant. It's just the transfer of the male reproductive cell to the female reproductive structure in the flower. And if you look at a flower, that's not a very big job to get from here to there. I mean, it seems like you wouldn't need help with that. And some flowers don't. A lot of beans and peas, your legumes, all of them are self-pollinating. But for most other flowering plants, you need to get that pollen to another flower. And that's a little bit harder. So we want to outcross, and that benefits plants in a lot of different ways. Primitive plants were wind pollinated. They didn't need bees or anything else. They just relied on the wind. And a lot of things are still relying on wind, maybe about 10% of plants. A lot of conifers, oak trees, pine trees, most grasses, most cereal grains are wind pollinated. So, the last few weeks, maybe you've noticed a lot of green dust on everything in your sidewalk, on your driveway. Those are wind-pollinated plants that just have to dump billions and billions of pollen grains out there and hope for the best. It's very expensive metabolically for plants to produce pollen. A pollen grain is full of energy, it's packed with proteins and carbohydrates and other things, and so it costs a lot for plants to make all that pollen. On the other hand, sugar is cheap for plants to make. They're just photosynthesizing, so if they just make a little bit of cheap sugar, nectar, they can invite a pollinator to visit, reward it for doing so, and then slap a little bit of pollen on the side of that bee or whatever, and it will deliver it directly to another flower. So it's a lot cheaper for the plants to do that. And if you look at the history of plants, going back as far as plants go, originally they were just algae and things like that. We had ferns and bryophytes, but we get up into trees, and then suddenly, around in the Cretaceous period, the angiosperms, the flowering plants, develop. And pretty soon after that, geologically speaking, bees show up, and there's this huge radiation, this speciation of flowering plants. We have more species of plants than you would believe, and a lot of that has to do with their association with flowers. There's still about a 10-20 million year gap in there before bees arrived. So something else was filling up that niche in nature. And one of the earliest pollinators was probably beetles. Beetles were crawling around on flowers, and they realized that, hey, this pollen is good to eat. And they would get pollen grains stuck to them, and they would carry it around, and that really benefited the plants. Early flowers were not the delicate little things that we're looking at in a lot of our gardens. Think about magnolias. Big, tough flower, right? That's what dinosaurs used to give each other for corsages on prom night. Those are the kind of those are the kind of plants that were around with these early pollinating insects. So they made a kind of a cone with seeds in it, not a fleshy fruit, but they had big fragrant flowers with tough leaves and thick petals. And so a lot of beetles still crawl around on flowers today. This bottom one in the middle, I don't think you can see the pointer there on the screen, but that's a beetle, but it's a bee mimic. It looks like a bee. That's how it protects itself. It has no stinger, but if other creatures see it, they're kind of shy away from it because they think it's a big old bumblebee. So it sneaks around and it helps to pollinate, but it's very fuzzy and it gets the job done. Flies can also be pollinators. Most people don't appreciate flies, but they actually do a lot of important jobs in nature. And a lot of flies are nectar feeders. Even mosquitoes feed on nectar. Male mosquitoes don't drink blood. They feed exclusively on flower nectar. They just need the sugar, a little fuel, a little energy to get the job done. And of course, their only job is to find a female mosquito. They're just looking for love. The females need that blood so they get protein in order to lay eggs. But in the process of visiting flowers, a lot of them do spread that pollen around. Some of the largest flowers in the world depend on flies. If you go to Indonesia and Southeast Asia, you have these huge flowers that smell like rotting flesh. They're stinky and disgusting. They smell like day-old roadkill. And if you're a fly, there's nothing more attractive, right? So the flies go in, they wander around looking for that big hunk of dead meat. And in the process, of course, they get pollen all over their bodies, because they're fuzzy too. And they carry that to another one. They crawl out thinking, man, what a ripoff. And then they fly off and they smell something else delicious, and they spread that pollen around. If you've ever eaten chocolate, you've got a fly to thank. Cocoa beans, cocoa trees, the flowers are pollinated exclusively by a tiny little fly called the chocolate midge that does really well in a rainforest where it's dark and humid, very wet, and of course people love chocolate, so we plant them in big plantations where the trees are spread far apart so that people can get to them easily and they're in lots of sunshine, and you don't get near as many cocoa beans that way. But people don't seem to be able to catch on to the fact that the trees, they know best. The flies, they know best. So keep going with what they had. These are bumbleid flies. Again, harmless, no stingers. Aren't they adorable? They look kind of like bumblebees. Some of them even have stripes on them. But they've got a long beak like a hummingbird. They fly down and they sip on nectar at a flower and they carry pollen away. But again, their disguise is that they look like bees. So they can't hurt you, but other things don't know that. So we'll keep the flies secret. These are serpent flies. They're called hover flies. You see them all the time in your garden, and you think they're bees or yellow jackets because of their coloration. They're very beneficial. They do pollinate, but they lay eggs on your plants, and the eggs hatch out into a little maggot. We don't like that word maggot, right? That's creepy. We associate that with filth, but a fly larva is a maggot. They crawl around and eat the aphids on your plants before they pupate and turn back into a little fly. So we've got all kinds of them, big ones, little ones here. You recognize them by the way they fly. They call them hover flies. So they kind of fly very erratically. They'll hover and they zip in a straight line and hover. They do like a bee would never fly like that. These are very graceful. They fly in curves. But you see these guys, they can't hurt you. Try to catch one in your hand. You can't. We've all been hearing about the decline of bees now for over a decade, and all the newspaper articles and magazines that come out with headlines, it drives me crazy when I see this, because newspaper editors say, give me a picture of a bee, and somebody goes online and they get a picture of a fly, because they don't know any better. You see it in reputable news sources, and you see it a lot in pop culture. Maybe you've seen this movie, The Secret Life of Bees, the cover, that movie poster covered in flies. And then I ran across this product, and I thought, well, maybe that's fitting. This is fake honey, so they have a fake bee for a spokes insect. So I'll let that one slide. Who likes wasps? No takers here. One. We got one wasp lover. Wasps are incredibly important for pest control in your garden. You've got big ones that take out caterpillars and tiny ones that take out aphids. But they are voracious predators of all kinds of spiders and insects, and they keep those other things in check, keep their numbers in balance. But a lot of wasps are also pollinators. Again, while the females may be predators, males typically just feed on nectar. They're sweet like that. You are what you eat, right? And they pick up pollen as they go along. Anybody here grow figs? You have a fig tree? Do you ever see a fig flower? You do? What does a fig flower look like? You don't. The fig tree just spontaneously puts out, oh, let me back up. This is another wasp. That's not a fig. That's not a fig flower. That's actually an orchid. This is a case where the males actually do a good job of pollinating because the orchids have tricked them. The male wasp is rather nearsighted, and the flower disguises itself as a female wasp. And he's flying along and he says, hey baby, what's going on? I'm going to come down there and see what's up. Biologists call this process pseudocopulation. I'll let you figure out what that means. He lands and he picks up some pollen on his body, and then he goes away disappointed, and then he sees another little lady on a flower and says, hey baby, what's happening? And he spreads that pollen around. So they're taking advantage of the natural inclination of that wasp, and he spreads some pollen around. But back to figs. I got ahead of myself. So this is what you see. You see this little green fruit just appear spontaneously on the fruit, on the tree. And then later on they turn colors, right? They ripen and they're delicious. The very end of that fig has a little hole in it, a little pore. The flowers are actually inside the fruit. It's an inside-out fruit. It's pretty wacky. And there's a little wasp that crawls in and pollinates those flowers. She carries the pollen in, then she lays eggs inside that fig, and it forms a gall inside, and the egg develops. And the little boy and the little girl wasp hatch out. They mate inside your figs, and the males die right there. The females wander around, and they have to collect pollen, and then they exit your fig and go find another one. If they don't do this step, then when they go and find another fig, they can't spread pollen around, and that fig does not develop. And if the fruit doesn't develop, then the little baby wasps don't develop. The fig just falls off, and everybody dies. So they've got to gather pollen and go out and find a new fig. So the next time you're enjoying a fig Newton, or some nice fig preserves, a little fig jelly there, you can think of that there's a little value-added product there, a little bit of extra protein inside of your figs. I have just ruined figs for this nice lady here. Well, there's power in information, and there's ignorance and bliss. Bliss and ignorance. Yeah. Who likes butterflies and moths, right? Everybody does, right? Some of the most voracious pests in agriculture are caterpillars, the larval stage of these lepidopterans, these horrible creatures. Just a stomach with some tiny little legs and a mouth with a big old set of teeth in there. They just chow down on all of your plants, and then they fly off and look for some more. But of course, butterflies and moths are important pollinators. They feed on nectars. They've got this long proboscis. They can get down in the flowers, and they pick up pollen on their fuzzy little faces, and they carry it away. A lot of flowers actually specialize in butterflies. Some flowers have these special structures. When a butterfly lands, her foot goes down into a little hole on the edge of the flower. Milkweed flowers have this. Some orchids have this. A lot of things in the poinsettia family have this as well. But when they get their foot stuck in there, they pull up this little sticky pollen-bearing structure here called the pollinia. It kind of sticks to them, and as they fly along, they've got this kind of bag of pollen that they carry to the next flower. And sometimes you'll see them stuck all over the butterfly's feet, but you'll also see them stuck on bees. Bees aren't quite as strong as butterflies, and so sometimes they have trouble pulling their legs out of them. And occasionally, on a milkweed, you'll even see a dead bee hanging there because she can't quite get her leg unstuck from that pollen structure, and she hangs there, dangling, struggling until she starves to death. Terrible, isn't it? Well, one bee out of many. It's kind of a drop in the bucket. I feel sorry for that one, but they're still doing the job. Who's a better pollinator, bees or butterflies? What do you think? Bees? Maybe. Kind of depends on what kind of flower you are. Bees have a central nest. They radiate out, and gather all the pollen and nectar they can in the neighborhood and bring it back home. But butterflies don't have a house, so they just flutter along through the forest, across the meadow. So if you happen to be a flower that grows in small isolated patches, then butterflies and moths and things like that genetically connect little isolated populations of flowers as they travel along. Some migrate, like the monarch butterflies, migrate thousands of miles, and they help to spread that pollen long distances. Whereas bees stay in their own neighborhood, they take care of things really well where they are, but they're not gonna travel a long distance. So they're both good, they both work different systems, and they both have different roles to play. And as I said, butterflies and moths are horrible pests. They fly long distances, they lay a lot of eggs, and their larvae are just eating machines. Some of them are highly specialized in what they will feed on. So when they find what they like, they go crazy, which is what makes them such a pest on a farm, because that one plant that they really love, we plant 1,000 acres of soybeans or cotton or corn or whatever it is that they like. And so their populations can get out of control really quickly. You may even recognize some of these in your gardens. But because they have such a specialized palate, like this one, this is a pyralid moth. It only eats prickly pear cactus as a larva. Prickly pear cactus has been introduced in a lot of places accidentally, and it was brought into Australia accidentally, and it's taken over a lot of area in the outback that is rangeland for cattle. And in order to control it over a large area, they introduced this moth. It hasn't eradicated the prickly pear, but it helps to control it, it slows its spread, and so this little moth is doing its job to help out and kind of keep the prickly pear under control. Who likes bats? You should, because they love to eat mosquitoes. And they are also important pollinators. A lot of plants really depend on bats. There's a lot of fruit trees and things in the tropics that need bats, but in deserts they are really important because a lot of floral resources are few and far between. There's one very important cash crop that relies on bats, the blue agave cactus, which you see here. And of course, that's what you need for margarita night. No tequila without bats. They pollinate those flowers, so gotta have bats around for that. Other mammals can also pollinate. Lemurs pollinate. They're found in Madagascar. The Australian honey possum and the sugar glider, both again in Australia. You typically find oddball pollinators in island situations where there may not be a lot of bees and other insect pollinators, so other types of creatures kind of move in and fill that niche. But these guys all love to feed on nectar, they feed on the pollen, and in the process they get pollen all over their faces. Carry it from flower to flower. There's even some reptiles that do that. There's some little geckos, and this little Japanese skink loves to feed on nectar, and they get pollen stuck to their scales and they move it around from flower to flower. And of course we're familiar with the hummingbirds. You see them at flowers, so obviously they like to feed there, and they pick up pollen as they do and carry it around. But many other birds also feed on pollen and nectar in deserts and rainforests and all kinds of places. So many different birds help out with pollination. But of course, then there's the bees, the perfect pollinators. You could not design a robot that does a better job than a bee. That's all they want to do, is what you see them doing right there. Going from flower to flower, sipping a little nectar, carrying that pollen around. Nothing makes them happier. They're super smart. They have to learn how to approach a flower and find the nectar. They've never seen a flower before in their life. The first day out of the hive, and they go right to work. And if they encounter a different kind of flower, they have to learn that too. So they're natural puzzle solvers. There's about 20,000 different species of bees in the world. We're going to cover them all before I'm done talking here. Take notes, I count off the spelling. But look at those pictures. There's red ones and blue ones and green ones and orange ones. Some are super fuzzy, some almost look bald, some look metallic. Most bees do not live in hives. They live in the ground or all alone. They're solitary bees. Very few bees live in colonies like the honeybees and bumblebees that we're familiar with. There are more types of bees in the world than birds and mammals put together. Way more. That doesn't count the other million types of insects. That's just the bees. Here in North America, there's about 4,000 species of bees. And there's at least 400 types of bees just here in Arkansas. We're currently doing research to catalog them, find out what we've got here and how many and where they are. But nobody knows because most of them are really understudied. We know a lot about honeybees, they're economically important, but now we're starting to realize that all these other bees play a big role too. One species that is not native here is the honeybee. They came over from Europe in the 1600s. When people brought cattle, pigs, chickens, horses, all their favorite livestock, they brought honeybees as well because they produced something that nothing else could, honey and beeswax, which was a very important commodity at the time as well. The only species of honeybee kept in North America is this European honeybee, or the western honeybee. It's the same species found in Europe and Africa, and it's been brought everywhere in the world where there's flowers. There's other species in Asia that we consider honeybees, but even over there, they prefer the European honeybee because it's the most productive and the easiest to manage. So it's the preferred pollinator anywhere you go. They make very large colonies. One hive of bees can hold anywhere from 20 or 30 to maybe 50 or 60,000 individuals. So that's a big workforce. And they like to live inside of a cavity. In nature, of course, that's a hollow tree or something like that, but we can convince them to live at ground level in one of these nice little white boxes. And it's convenient because bees only fly during the day. At night, they'll go inside. You can close that entrance at the bottom, put it on a truck, and you can haul it cross country. And when you put them down, they come out and they say, well, I've never been here before, but time to get to work. And they will visit the orchards or whatever crops, whatever farm you put them on, and they'll go straight back to doing their job. Honeybees are the only insects that don't go dormant or die out in the wintertime. That whole entire colony stays active all winter long. The whole colony is perennial. Individual bees don't live long, but as a group, that whole colony feeds on the honey they've collected. They stay active, keep themselves warm, and so they're ready to go when the first crops are in bloom in the springtime. There's one crop that blooms in California that's very important to honeybees, almonds. They grow 80% of the world's almonds in the Central Valley of California and requires almost 2 million colonies of bees. California can't support that many honeybees the rest of the year, so they truck them in from all over the country. And once they're done with almonds, in about 4 to 6 weeks, they move them into other crops, and bees are traveling all over the country. Probably 9 or 10 months out of the year, bees are on the move. So it's a huge industry. But the almond industry really subsidizes the beekeeping industry in this country. So if you wonder why almonds are so expensive, it's because you're also paying for the beekeepers to truck them in. Honeybees are generalist feeders. No matter where you put them, they can find something to eat. Many types of bees are very specialized in what they'll feed on. They only come out for a few weeks when their particular flower is in bloom, then they go away again. They'll emerge again next year. Bees also practice floral fidelity. So this means that on each trip outside of a beehive, a honeybee will only visit one species of flower. So if they're working in your peach trees, they're not going to go to a rose bush, hit a clover, down to a dandelion, over to a buttercup, and then get back to your peaches. Because that would waste all of that pollen. They carry peach pollen from peach blossom to peach blossom to peach blossom. Later on, they might try a different flower, but on this trip outside the hive, they stick to one thing. And that makes them very efficient compared to some of the other pollinators out there. They also talk to each other. They do a little figure-8 dance inside the hive that tells the other bees what they found, where it was, how far away, and how good that source of food is. So this little bee that's dancing here, this little figure-8 dance, she's telling her friends, go outside, look at the sun, turn about 15 degrees to the right, and fly this far, and this is what you'll find. Have a free sample of nectar. And then smell me. I've been rolling around in the peach blossoms. I smell all peachy. So these other bees, they say, that tastes good. That smells good. All right. Let's see. There's the sun. We'll turn this way. We fly that far. Oh, I smell peach blossoms as I approach. So one bee recruits 10 friends. 10 friends return, and they recruit 10 friends each. Now you've got 100 bees. They go back home. You got 1,000. You got 10,000 bees in your peach tree because one bee happened to be flying along, thought it was a good place to feed, and told everybody else back at the hive. But peaches don't bloom very long, right? Maybe a week or two. Most flowers are very ephemeral that way. They're not out very long. Some are, they'll last a whole season, but these floral resources come and go. So it's important when bees are in competition with all the other beehives in the area that they find it and they tell all of their friends, all their family members, go out and get it while it's good. And of course we like bees because they produce food for us, and they make a lot of it if conditions are right. Honeybees will produce much more than they need to get through the winter, and so as a beekeeper, I can take a portion of the bees' honey, and then I can leave the rest for them. So, as the bees' landlord, this is how they pay their rent. So, as long as I'm careful and I leave enough for the bees, then we're good to go. So, there's many benefits of keeping honeybees. Of course, you get honey. Beeswax is also an important commodity. You can make all kinds of stuff out of that. Lots of cosmetics, of course, candles come to mind. Beeswax is the highest quality natural wax you can get. It's got the highest melting point, so it makes the best candles. You can make a long, tall taper out of beeswax. You can't do that with soy wax or paraffin. That's why all your scented candles that you buy at the mall, they're all in a glass jar, because if you tried to make a candle out of that, a tall one, they would just melt into a big puddle because they have a very low melting point. So beeswax is the best. Bees also produce this stuff called propolis. They go out to trees and they collect resins and tree saps and bring it back, and they smear it on everything inside the hive. And it's actually antimicrobial. It's got amazing health benefits. It's supposed to boost your immune system, but everything in the hive is covered in a paper-thin layer. They use it to caulk cracks and crevices. Anything that's not supposed to move, the bees will cement it into place. And as they walk through their hive, it cleans their feet. So they've been out foraging, they come back in, they just walk up the wall, it's like washing their hands. But it's just another product that you can harvest from a beehive. And you can buy it in a health food store. It's supposed to be great for all kinds of things. You can even collect bee pollen, bee-collected pollen. As the bees come into the hive, they will walk through a screen you put on the front door, and it takes the pollen, kind of shakes some of it off of their back legs where they carry it, and you can collect it and put it in jars. A lot of people take it to help their allergies. If somebody's going to ask me, does that work? It works for some people, not for everybody. So I'm not that kind of doctor. I can't make that kind of guarantee for you. But it's full of nutrients, proteins, vitamins, all kinds of stuff. And so a lot of athletes take bee pollen because it's full of energy, and it's got lots of benefits. You can also use bees for pollination. That is the number one thing that bees do for us. That is the major economic driver of beekeeping. Commercial beekeepers don't get squat for honey. You look at the honey in the supermarket, it's like $3 or $4 a pound. You go to the farmer's market for some fresh local honey, it's $7, $8, $9 a pound. Your commercial beekeeper gets maybe $1 or $2 because they're selling it to the big packers in barrels, but they are making their money off of renting bees out for pollination. And so that's what they have to do, and the scale of agriculture in this country is so huge, there's a big demand for that. And so most of the bees, about 90% of the honeybees, are owned by a handful of operations that carry them around. But about a third of your diet depends on bee pollination, insect pollination, either directly or indirectly. And honeybees, this one type of bee, does most of the important pollination work on most crops. Excluding cereal grains, but just about anything in your diet that's colorful, probably bees have a hand in that. They add about $30 billion to the economy every year in terms of bigger and better produce, fruits and vegetables. So better quality, better quantity of fruits and seeds and things. There are some self-pollinating plants, like legumes, and there are wind-pollinated things, like cereal grains, but most angiosperms, most flowering plants, benefit from crossing with other types of their species. So you need a pollinator for that, of course, and a pollinizer, another plant that produces pollen. If you've got one apple tree, you can get some apples, but if you have 2 apple trees, you're going to get a much better crop of apples because that your tree is not trying to breed with itself. You get a little bit of genetic variability there. So in addition to pollinators and pollinizers, we need good weather when those flowers are in bloom. You know, your fruit trees in your backyard, your orchard, they don't bloom very long, and they do it in the spring, and you get a week like this where it just rains and rains and rains, sometimes worse, right? Bees don't fly in the rain. That would be like you getting hit with a 20-gallon water balloon constantly, every 5 seconds, again and again. Bees are going to stay home in the wet weather. And so you don't notice it, but you can hardly have any apples come fall because you didn't get good weather during that bloom period. Also, you have to think about what else is in bloom around. Some things produce a lot of nectar that bees love, some things don't. Pears, for instance, they produce pollen, not a lot of nectar. If you want to grow pears, you might have to bring in more bees. That way, every flower's got a bee on it. Some poor hapless bees got to go work the pears. They didn't want to. There's very little reward for them, but all the other flowers got taken, so somebody's got to work the pears. You know, in big orchards, they mow down the ground cover and things like that so that the bees will concentrate on the fruit trees. And of course, all of the ovules in that flower have to be fertilized. When a pollen grain lands on the stigma, it has to grow a tube all the way down in order to fertilize that cell called an ovule. Kind of like fertilizing a sperm and an egg together. And that ovule is what becomes a seed. And the structure around it is what becomes, it's called the ovary, that's what becomes a fruit. So if most of those ovules don't get pollinated, then the seeds don't develop. And then you don't necessarily get good fruit. Sometimes it's deformed. Maybe you had an apple that was lopsided. If you cut it open and look, there's only seeds in half of it. The other half, the scrawny half, you could say, there's no seeds there. Sometimes the fruits are just smaller. Sometimes they don't develop at all. Sometimes they start to develop, then they just drop off. You ever grow a cucumber like that? What's going on there? The only reason that plant is producing a fruit is so that some herbivore will eat it and swallow the seeds and drop them somewhere else in a big pile of steamy fertilizer. You know what I'm talking about. That's what plants want. They want birds to eat their berries and drop those seeds somewhere else. That's how they spread around. But if it can't make a viable seed, then this vine is not going to make a big old fat cucumber. That would be a waste of resources, so it just grows another flower further down the vine and tries again. So if you're getting results like this, it's insufficient pollination. You see things start to form, and then they just kind of shrivel up, or they never really develop. And they continue to flower. So these pollinators are really keystone species. They've got a small size, but they've got a huge impact for what they do in nature. Their ecological role is much larger than their actual size. And so think about their role in the food web, not just for our food, but for everything else that likes to eat. You know, plants are the basis for the whole food chain. If you don't eat plants, you eat something that ate plants, or you ate something that ate something that ate plants. It all comes back down to plants. The entire terrestrial ecosystem revolves around plants feeding on sunshine. So our food and all the wildlife out there, all the little nuts and berries and seeds that birds and bunny rabbits and deer and even bears. Bears aren't big hunters. They eat beetle grubs and berries and all kinds of things. They're omnivores. So everything depends on the stuff that these bees are doing for us. So bees are indicator species. They are the canaries in the coal mine, and they're trying to tell us something right now. There's an alarming decline in not just the honeybee, but all bee species, all pollinator species, honestly, a lot of insect species in general. And insects do all the dirty jobs you don't want to do. You may not appreciate flies and dung beetles and termites, but their job is to take what we don't want and turn it back into soil, recycle those nutrients, and put them back out there so that you can grow a nice juicy tomato or a strawberry, or you can have a crisp apple, right? So all of those other insects are doing super important jobs. What's going on with them though? What's causing pollinator decline? The easy answer is, oh, it's those guys with the tractors and the crop dusters. some guy sprayed up the road and now all my honeybees died. It's not necessarily that easy. There's no simple answer for it. Agricultural areas are not friendly to wildlife, but neither are the places we live. That is very unnatural. You bulldoze all the trees, name the streets after the ones we cut down, plant a 1/4 acre of zoysia grass, and you put a Bradford pear tree in the corner of each yard. That is not an ecosystem. You might as well put a plastic Christmas tree there for all the joy it's going to bring to wildlife. And urban and suburban homeowners are the worst abusers of pesticides. Because y'all don't read the labels. You don't have to have a license to buy a can of bug spray that's on the same aisle in the grocery store as cat food. It must be safe. It was $3, right? You can buy another one next week. The label says, use 2 squirts. How much are you using? That's right. You emptied that can, right? So, farmers pay a lot for those chemicals. They're not going to use any more than they really have to. So there's no single easy answer for the decline of bees, but a lot of it just has to do with the way that we have changed the world that we're living in. There's pollution, and there's pesticides, and that's definitely part of it. There's also diseases and parasites that are spreading diseases and weakening these. And with global trade and travel, we're moving insects and diseases of insects all over the place. But one of the main reasons that insects are having trouble in general is habitat loss and fragmentation. The habitat that is left is tiny little patches here and there, but there's nothing that connects them. There's nothing that lets wildlife travel back and forth between these areas that we leave in. So they have these tiny little islands. So that's really the main driver of loss of insect diversity and just poor health. So if you want to save the bees, don't necessarily need to become a beekeeper, although we welcome you if you do, but conserve and enhance wild habitats. Plant more flowers. Those isolated habitats need to be connected. We need more flowers growing in between them. And of course, reduce pollution and pesticide use and things like that, but mostly just use common sense. You don't want to live in a world without bees and birds and butterflies, so you need to create a world where the bees and the birds and the butterflies are happy and can thrive. If it's good for the birds and the bees, it's good for all of us. Thank you. Yes, sir.
Question: you were saying you could take so much honey. How do you determine how much honey you can take from a hive?
How do we determine how much honey we can take from a beehive? That's a good question. The best teacher, of course, is experience. In our climate, bees are going to need around 45 to 50 pounds of honey, an average-sized colony, to make it through a winter here. And so you kind of judge that by how much honey is in the hive, and there's different sizes of boxes that we put on the beehives. So what we call a medium holds about 35 pounds of honey. A deep holds about 60 to 70 pounds of honey. So it's kind of somewhere in between there, but it's something that we just have to learn how to judge. And if we do take more, then we have to feed them a sugar syrup, which is not as good for them, but it can get them through. Any other questions? Anybody here interested in becoming a beekeeper? I've got a free online beekeeping short course. If you go to this website here, then you can take that. You're laughing because you're already a beekeeper?
No.
Okay.
I just don't like it. I love bees.
All right.
I get stung.
Well, then you just need a good bee suit and learn how to work them very gently. None of us like to get stung. That's the question people always ask you when you're a beekeeper. Do you ever get stung? You sure do. Yes?
Did bees evolve from wasps?
Do bees evolve from wasps? Yes, we believe that bees did evolve from wasps. A specific group of wasps called the specids, the thread-waisted wasps in the family Specidae. They're the dirt daubers and the mud daubers. They make that mud nest on the side. We think that bees, all the bees that exist now, emerged off of that group. And they were predators, and they became vegetarians, and they kind of went their own way. But yes. Okay. Thank you all very much.